Have you ever stopped to truly consider what it's like to see the color red?
Hmm.
Not just, the wavelength or how your brain processes it, but that really private, intense sensation, that redness.
Exactly. Or that ache of longing.
Yeah.
Or the absolute joy from a perfect piece of music.
Right. These subjective, qualitative things.
Mm.
The what it's like of being conscious.
Mm.
They're what philosophers and scientists call qualia.
Yeah.
And today, we're diving into something fascinating. Can we apply a kind of mechanics to these incredibly personal
It
experiences?
sounds almost contradictory, doesn't it? Mechanics for feelings.
It really does. We're exploring this idea of qualia mechanics. It's not a formal scientific field yet. Definitely not.
Not yet, but it's a concept that's definitely gaining traction. You see different researchers kind of converging on it.
Yeah, from different angles. Interdisciplinary work trying to formalize the structure, maybe even the behavior of qualia.
That's right. And our mission today for this deep dive is really to explore these cutting-edge developments, everything up to 2025. We're looking across neuroscience, consciousness studies, mathematical modeling,
Yeah.
even some pretty speculative metaphysics.
Oh, okay. Broad scope.
Has to be. They're all trying to bridge this huge gap, between the objective brain stuff and our subjective world.
The hard problem, essentially.
In essence, yes. So by the end of this, you should have a really good, quick, comprehensive grasp of where the science and philosophy stand on this frontier. It's a truly fascinating area.
It sounds it, because historically this has been the problem, right? How do you study something so inherently subjective?
Exactly. For centuries. How do you measure a feeling?
Right. How do you put a number on warmth or the taste of, I don't know, chocolate?
You can't easily stick a probe in it. It's private. And that's made it incredibly resistant to traditional science.
So what's changing? Why talk about mechanics now?
Well, that's precisely where this emerging idea of qualia mechanics comes in. The ambition is shifting.
How so?
It's moving beyond just describing qualia, red feels like this,
Yeah.
to actually trying to understand their underlying mechanisms.
Oh, okay, like the how and why.
Exactly. Their structure, how they behave, maybe even how they interact. A bit like we study particles or forces in physics.
That's a big leap.
It's a huge leap, trying to find universal patterns and experiences that feel completely individual. That's the goal.
Okay, so where are people actually trying to do this? You mentioned empirical work.
Yes, one of the most solid empirical efforts right now is the Qualia Structure Project.
Okay.
It's funded by Japan's JSPS Transformative Area, a big multi-year initiative.
And what are they doing that's different?
Well, a really innovative part is how they're mapping what they call high-dimensional similarity spaces between different qualia.
High-dimensional similarity spaces. Okay, unpack that.
Think of it like this. You don't just plot colors by wavelength, right? Imagine plotting feelings. Joy, anger, sadness in a conceptual space.
Okay.
But not just 2D or 3D, maybe dozens, hundreds of dimensions. The proximity in this space shows how similar or different they feel. It captures really subtle nuances.
So mapping the relationships between feelings based on how they feel.
Precisely, and they're doing this for visual qualia, emotional qualia. Their recent work, like Dr. Nicolo Negro's paper published in Synthes in 2025, it's making real strides in actually quantifying and modeling these complex relationships.
So they're finding structure.
Yes, that's the key insight. It's not just that we can map them, but that doing so reveals these surprising, perhaps universal patterns. It suggests qualia aren't just random noise. They have an inherent, measurable structure.
That's fascinating. And you mentioned this is getting attention.
It really is. A YouTube summary of their project got, nearly 200,000 views?
Wow.
It shows a real public hunger to understand this stuff. It highlights how foundational this kind of work is, establishing measurable, structured relationships. That's a step towards the mechanics.
Okay, so that's the empirical mapping side. What about, well, you mentioned math earlier. Are people trying to describe these structures mathematically?
Absolutely. That's another major thrust. And here you have groups like the Qualia Research Institute, QRI.
Ah, yes, QRI, based in Silicon Valley, right. They pop up a lot in these discussions.
They do. They're definitely at the forefront of mathematical consciousness research. Very influential.
So what's their core approach?
Well, a couple of key ideas. One is qualia formalism.
Okay.
The basic proposal is that qualia, the subjective experiences themselves, actually correspond to mathematical structures. Like, the feeling is the math, in a way.
That's a strong claim.
It is.
Yeah.
And tied to that is valence realism.
Valence. That's the pleasantness or unpleasantness.
Exactly. Valence realism suggests that this pleasantness or unpleasantness isn't just subjective opinion, but it can be objectively quantified.
Objectively, like a number for happiness.
Potentially, yes.
Yeah.
They believe you could maybe one day have a universal valence score, an objective happiness meter, if you will.
That's mind-bending.
It is. And they build theories on this foundation.
Like what?
Well, there's Michael Johnson's symmetry theory of valence. Yeah, the idea here is that the valence, how good or bad something feels, correlates with the mathematical symmetry of the qualia state structure.
Explain that a bit more, like musical harmony.
That's a good analogy.
Right.
Just like a symmetrical, balanced piece of music might feel harmonious, maybe our most pleasant feelings are linked to the most mathematically orderly or symmetrical patterns in our brain activity.
Interesting. Okay, what else?
Then there's their topological segmentation theory.
Topology. Okay.
This one suggests consciousness itself arises from how electromagnetic fields in the brain get segmented or partitioned.
Segmented fields, like channels.
Kind of. Imagine the brain's overall electromagnetic activity isn't just mush, but it naturally forms distinct, meaningful regions or patterns of experience. Those segments are consciousness in this view.
Okay. Complex stuff. And there was a third one.
Yes, neural annealing.
Annealing, like in metallurgy, metalworking.
Exactly like that. The idea is that energy dynamics in the brain, how energy flows and settles, influences the plasticity and structure of qualia.
So experiences can be set or softened?
Sort of.
Yeah.
High energy might harden a memory or experience, making it more stable. Lower or fluctuating energy might make qualia more fluid, adaptable. It connects brain energy dynamics directly to the character of subjective experience.
These are definitely abstract theories. Are they just theoretical, or do they test them?
Well, they try to bridge theory and practice. They even ran something called a psychedelic cryptography contest between 2023 and 2025.
What contest?
Psychedelic cryptography. Yeah, kind of
Wait,
wild.
so what on earth was that about?
It explored how altered states of consciousness induced by psychedelics affect information processing and the perception of qualia, trying to see if their computational frameworks could model or predict those changes. A very unique testbed.
That is unique. So QRI is really trying to build computational models of this stuff.
Absolutely. What's crucial here is that their work is probably among the most technically developed efforts to actually mechanize qualia.
Right.
They're explicitly aiming to bridge the gaps. Neuroscience, math, phenomenology, all within a computational framework. That's a direct line to this idea of qualia mechanics.
Okay, so QRI is focused on math within the brain structures. Are there even more abstract mathematical approaches?
Oh, yes. Some researchers are looking at really high-level math, concepts borrowed from physics.
Such as?
There was a 2025 preprint by at Kinerjate, for example. It explored using principal bundle geometry.
Principal bundle geometry. Okay, that sounds intense. From mathematical physics?
Exactly. Highly abstract. But the idea is maybe this kind of geometry can describe the fundamental shape or structure of experience itself.
The shape of experience.
Yeah, using things like gauge theory, topological math, trying to model how qualia might emerge from structured perception, reflecting deep symmetries.
Symmetries again?
Seems to be a recurring theme, doesn't it? But it's important to stress, this is very speculative.
Lacks empirical backing.
Right. It's mathematically sophisticated, but connecting it back to actual brain measurements or subjective reports. That's the huge challenge there. Future work needed, definitely.
Okay, so we have the empirical mapping, the computational models, the abstract math. What about standard neuroscience? How does it fit into this picture of mechanics?
Neuroscience is obviously critical. Research into the neural correlates of consciousness, the NCCs, is all about this.
Finding the brain bits that correlate with experiences.
Exactly. Mapping specific brain patterns to specific subjective states. And there's fascinating speculation now about large language models, LLMs. Could they maybe exhibit something analogous to qualia if they were trained or structured in ways similar to biological brains?
Whoa, AI qualia, that's a whole other can of worms.
It is. And more concretely, functional imaging studies, fMRI and such, in 2025 are starting to suggest overlaps.
Overlaps between what?
Between brain regions involved in perceptual memory and those seemingly involved in generating qualia. It hints at shared pathways, maybe shared computational principles.
Which could help build models.
Precisely. These neuroscientific insights are vital. They could provide the ground truth, the constraints for computational models of qualia, especially as neuroscience and explainable AI start talking to each other more.
Explainable AI. Trying to figure out why the AI does what it does.
Right. If we can understand the mechanisms in AI and map them to brain mechanisms, maybe we get closer to understanding qualia generation, potentially even the blueprint for, well, feeling machines.
That's a staggering thought. Okay, so we've covered science, math, computation, but you mentioned metaphysics earlier. Does this whole quest push into philosophy too?
Inevitably, the nature of qualia is a deep philosophical question, and some
Mhm.
thinkers take it into metaphysics. Peter Wilberg's 2025 book, The Qualia Revolution, is an example.
What's his angle?
He pushes back against the idea that qualia are just brain phenomena.
Suggesting they're more fundamental.
Exactly. Maybe qualia are fundamental constituents of the cosmos itself, not just emergent from brains, but woven into reality.
Wow. Cosmic qualia.
Sort of. He talks about qualia having gestalt structures, maybe toroidal, donut-shaped, or other topological
Oh
forms.
my, those shapes.
He argues these allow for both bounded awareness, like our individual experience, and potentially unbounded awareness. He even critiques standard quantum physics for, in his view, failing to explain subjective quality,
And propose
a
it?
primordial awareness field. It's highly speculative.
Definitely non-empirical.
Oh, absolutely. But it represents a kind of metaphysical mechanics trying to ground qualia in some ultimate cosmic geometry. It really does make your brain hum thinking about it.
It certainly does. And all these attempts from the lab bench to the cosmos, they're all happening against the backdrop of these huge philosophical debates, aren't they?
Absolutely. These debates frame everything. You have David Chalmers, who's still refining the hard problem in 2025.
Why subjectivity exists at all.
Right. And his philosophical zombie argument, could you have a physical duplicate with no inner life? That challenges purely physical explanations.
Then there are the skeptics.
Like Daniel Dennett, he argues qualia aren't special intrinsic things. For him, they're more like illusions or summaries that emerge from complex cognitive processing. They're a result of how our brain works, not some extra ingredient.
And Marvin Minsky, the AI pioneer.
Minsky suggested qualia might be computational artifacts, like complex outputs of our mental programs. If so, they are mechanizable, in principle.
So these different philosophical stances really matter.
Hugely. They shape whether you think a qualia mechanics could ever be a complete physical or computational theory, or if there's always going to be a philosophical gap, or maybe even if the whole concept is misguided. It keeps everyone grounded, hopefully.
It feels like we've come full circle, almost back to that first problem. Measurement. If you can't measure qualia directly, how can you build a mechanics?
It remains the crucial bottleneck, the grand challenge.
But there's progress.
There is. As we discussed, that Qualia Structure Project is explicitly trying to define these multidimensional similarity metrics.
Finding ways to quantify the relationships between qualia, even if not the qualia themselves.
Exactly. Objective measurement, even if indirect or relational, is absolutely the critical next step. Without it, models are just speculation. With it, you can start testing predictions about how qualia emerge, how they interact. That's how you move from description to actual scientific understanding. So to kind of wrap up where things stand in 2025, Qualia Mechanics isn't really an established academic field yet. You won't find a university department for it.
Right. Not like quantum mechanics.
Not at all. But what you do see is this convergence, a whole constellation of diverse research efforts in neuroscience, math, AI, philosophy, all implicitly aiming at the same goals.
Goals being?
Formalizing the structure, the behavior, the origin of qualia, trying to get a mechanistic handle on subjective experience.
Yeah, you can definitely see the threads connecting. You've got QRI doing the heavy math and computation, the Qualia Structure Project doing the careful empirical mapping,
Right.
these new abstract mathematical models popping up, exploring geometries.
All contributing pieces to what could become a future science of qualia, outlining the shape of it maybe.
So what needs to happen for it to become a true mechanics? Like physics?
Big breakthroughs, realistically,
So
especially in measurement, finding reliable, objective ways to quantify subjective states or their relations, progress in modeling, building testable computational theories, and maybe even getting more philosophical or metaphysical clarity on what qualia fundamentally are.
it's a tall order.
It is,
Yeah.
but the momentum is there.
Okay, so final thought then. Here's something maybe for you, the listener, to chew on. If we can eventually quantify and model the subjective, what it's like,
If I crack it,
what might that actually reveal about the nature of consciousness itself? And taking it a step further, what could that mean for artificial intelligence? Could we end up building machines that truly feel?